Collaboration between a human and an autonomous tangible interface can lead to frustration and conflicts of control. We present and validate a solution for sharing the control between the human and the interface. Our adaptive collaboration solution is based on two principles. First, the tool always communicates its intent to take control using minimal nonverbal gestures. And second, the human is always in control and can accept or reject the tool's intent to take control.
In a controlled lab study, we compared between adaptive and non-adaptive collaboration using identical tangible interface and task. Our findings show that adaptive collaboration leads to improved teamwork quality, better sense of control, and overall more positive perception of the shared control experience.
We used the previously published prototype that we developed at our lab. The original design process started with low fidelity prototypes and continued to a high fidelity. We implemented a unique mechanism with two motors, one for lean forward movement and one for headless rotation movement. We designed various non-verbal gestures by studying the movement of dancers and then implemented the gesture on the actuated interface.
We decided to use an anagram task to provide a clear shared goal for the collaboration between human and tangible interface. The anagram game consists of 4 Hebrew letters on a set of 4 pillars. Both the human and the system can rotate the pillars and construct words at the same time. The system can recognize correct or incorrect words and can complete words autonomously. Our proposed collaboration behavior for adaptive control is based on prior literature as well as pilot studies featuring 2 humans interacting with the actuated interface. The main insight that collaboration requires a common nonverbal communication language to resolve conflicts of shared control. Also pertinent, the need to anticipate the other party's intention and the need to request help when needed. In addition, we learned which natural gestures participants use as nonverbal common language and leveraged them in our final gesture design. Based on participants' continuous finger rotation to communicate "let's start over," we designed a full rotation of all pillars. Based on finger pointing towards oneself or towards the other to communicate a desired shift in control, we designed the signal as a gentle lean forward performed by one of the pillars.
We extended the existing prototype with adaptive collaboration behavior. The adaptive behavior is based on 3 aspects. First, prediction of human intent. The system sensed whether the user rotated the pillars or not, and measured the duration of inactivity. This enabled prediction of the user need to maintain control or to release control to the system. Second, communicating the system intent. When the system assumed the human is interested in releasing the control, it communicated its plans to take control using a physical signal. The signal was designed as a minimal nonverbal gesture. Prior work shows nonverbal gestures are perceived as social cues. Third, giving the human the choice to maintain or release control. We implemented a sensing procedure allowing the user accept or reject system suggestion to take control.
In a control study with 24 participants, we compared between adaptive and non-adaptive conditions in a counterbalanced order. The quantitative and qualitative findings show that the adaptive condition led to better collaboration. The qualitative measures indicated that the adaptive condition was experienced as fluent teamwork, while the non-adaptive condition was experienced as frustrating struggle for control.
Participants in the non-adaptive condition said, "If it takes control of a word and I wasn't planning to create the same word, it is super annoying." Participants in the adaptive condition said, "I understood what it wanted me to do. It didn't have to speak to me in words. Its movement was fully understandable. I felt that there was a synergy between me and the object, that we understand each other, that it flows." The quantitative analysis of the Godspeed questionnaire revealed that the adaptive condition resulted in significantly higher ratings than the non-adaptive condition.
To conclude, collaboration between humans and autonomous tangible interfaces can be fluent teamwork rather than a frustrating struggle. The adaptive experience was perceived as encouraging, supportive, and motivating, while in the non-adaptive condition, it was perceived as annoying, interrupting, and frustrating.
We hope that our work can inspire designers of tangible collaboration to add adaptive behavior to their systems. We offer 2 recommendations. 1, that a system should communicate its intent, and 2, that the human should remain in control throughout the interaction process and be able to decide whether they wish to accept or reject the system's help. Our findings show that adaptive behavior can lead to fewer conflicts of control, less frustration, and a better collaboration experience.